Optimize Genesis sequence.
Okay, good stuff. Hi, everybody. Wow. So good to see you all. Hey, before we get started, can we do the normal thing and take a selfie? Okay, good. Okay, I appreciate that, okay? Gee, where do I stand? I guess I can maybe more in the center. Okay, everybody, you know what to do. So pretend to be happy and take the photo. It's not hard. We can do this together, okay? Ready, steady, say open source. Oh, so cool. Thank you, everybody. Thank you, thank you, thank you. I'm gonna cherish those photos forever. I'm gonna take those photos and show them to my daughter, and I will say, see, they listen to me. So, my friends, I am so happy to be here with you all today. My name is Josh Long. I work on the Spring team as a Spring developer advocate. I'm also a Java champion, a Kotlin Google developer expert, and most importantly, I'm at your service. So if you have questions or comments or feedback or whatever, you can find me on the Bird website. Anybody using the Bird website anymore? No? Okay, burn it to the ground. We got email. Who's using email? Email. Anybody using email? No. Moving on. Good. Very embarrassing for me. I'm also a YouTuber. I'm not proud, but we gotta make a living somehow, right? So here's the internet. Who's torrenting? Maybe I should just tether off my own phone. I wonder if that's the thing I need to do. Okay, there you go. So yeah, join me on the internet right there. Coffee software. You can join me. It's not great. It's not bad. It's not the worst mistake you'll make, but it's not great either. There are better things you can do. So look, my friends, I am really excited to be here, obviously, and I was trying to figure out what I could do to show you also all the cool stuff that we're working on, And I thought, well, we could look at the old Spring Pet Clinic. How many of you have heard of the Spring Pet Clinic, right? Spring Pet Clinic. That's this sample application that we built decades ago. Here you go, Spring Pet Clinic. And the application basically is a demonstration of all the moving parts. Obviously, we've updated it in 20 years. It's here you go, last week. But I thought we could show you that. And do you know that the Pet Clinic actually has its own GitHub organization full of samples demonstrating how different kinds of pet clinics. Here's one with React and Kotlin and microservices and Angular and Spring Data JDBC and what else? You got VOD and Flow. You got Istio. You've got all these different versions. I thought, well, we could do that, surely, but that's just all. It feels like a lot. It feels like there's a lot of stuff there, And I don't know. That feels like it's going to be too much. So I thought, well, okay, let's not do that. But let's do something in the same spirit, in the same style, in the same vein as that. And so I thought, wouldn't it be great if we did something related to animals and dogs and cats and pets and whatever? And I love dogs, the pet clinic is all about adopting animals, right? And I love dogs. Everybody loves dogs. I love dogs. Except my dog. My dog's not a good dog. He's a terrible dog. It's just the worst dog. His name is Peanut. And he's terrible. He's a menace to people in my home. Not a good dog. But we keep him for 3 reasons, okay? First, most importantly, even bad dogs deserve a good home, okay? So even though he's not a good boy, we still love him and we keep him. That's one. And then part 2, the second reason, and I'm a little embarrassed to admit this, but the second reason is it's ego, okay? It's ego, okay? Because in my family, my partner and my daughter both speak 5 languages. But 3.5. So if we didn't have that stupid dog, then I would be the stupidest in the house, and that cannot stand. That will not stand, right? We keep him for a reason. And then the third reason, and I think this is sort of self-evident, is that he's just stinking cute, right? He's just really, I know. He's so cute on the outside and floofy, but pure evil on the inside. He's got a heart of malice, Not a good boy at all. Not a good boy. So he reminds me, my dog Peanut, he reminds me of another dog that I learned about during the pandemic. And this dog's name is Prancer. And this is the ad that the woman who had Prancer put out in 2021 to advertise this dog because she wanted to find a new home for this terrible, terrible dog. And so she put out this very famous, this went viral. It was on the news. Do you remember all the weird things we did in the pandemic? I watched the news. Like, that was one of those things, I mean, on a TV, you know, not like on YouTube and my iPad on the way to a flight. I was actually at home. So yeah, there was this ad for this dog, and she said, I've tried for the last several months to post this dog to make him sound palatable. The problem is that he's just not. There's not a very big market for neurotic, man-hating, animal-hating, children-hating dogs that look like gremlins. She continues, he's literally the Chihuahua meme that describes them as 50% hate and 50% tremble. And she keeps going, and she says, I was excited to see him come out of his shell and become a real dog. I'm convinced at this point, however, that he is not a real dog, but more like a vessel for a traumatized Victorian child that now haunts our home, right? So not a good dog. It sounds like this is a handful, you know? And I thought, well, what if we could build a service so that even Prancer could find a new home, you know? We could build like a dog adoption service. So that, my friends, is what we're going to do, okay? We're going to build a service. And in order to make this work, of course, I have a database. Let me just make sure I've initialized that database. Here we go. Go faster. Running. Okay, there. So I've got a database, and you've got some data in there. So what we're going to do is we're going to build a new application. And we're going to go here, as always, to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. Thank you. My first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. But if you've never been to production, you can begin your journey here at start.spring.io. And so what we're going to do is we're going to build a new application. We have some choices that we need to make, my friends. First of all, what do we want to call the service? Well, I'm going to call the service service. And the reason is because I'm amazing with names. Amazing with names. I get that from my father. He was amazing with names. When I was a small boy, we had a small white dog, and my father named him White Dog. Again, really amazing with names. Amazing with names. And I get that from him. So I shall call this service. We have a choice about what version of Java we want to use, friends. There are 3 radio boxes. You might be wondering why we don't have another radio box to the right of that number 17. And that would be Java 8. And the reason we don't have that is because there's no reason ever to use Java 8 in any context whatsoever, especially not in polite company. And in order to use Spring Framework 6 and Spring Boot 3.0, you need to use Java 17 or later. But I would never use even that, right? So in my mind, Java 21 and later are technologically superior in every way. They're faster, more robust, more syntax-rich, more performant, more operations-friendly. They're technologically superior in every way. They're also morally superior. You won't like the look of sadness and shame in your children's eyes when they see that you're using Java 8 in production. Don't do this. Be the change you want to see in the world. Do the right thing. And remember, Java 23 just came out. It's in the rear view mirror already. It's weeks old, almost a month old maybe, right? That means we're heading to Java 24. And at that point, the math should be persuasive because Java 24 will quite literally be 3 times better than Java 8, right? It's an amazing, amazing moment in time. So there's no reason to ever use Java 8 anymore, or indeed anything below Java 21. Java 21 is, in my estimation, the single most important release of Java ever. And we'll talk about some of those reasons why. But I'm a big fan. Java 21, 22, 23, 24, all very good. But if you could only pick one and you have to choose a long-term supported one, Java 21 is awesome, okay? So we'll use that. What else do we want? Well, we want the GraalVM native image support. We'll add that. We want the web support. We'll add that. I want to support modularity in my code base, so I'll use Spring Modulith. I'm going to build an assistant, and we're going to use some AI. So I'll bring in the Spring AI project and support for OpenAI. I need a database, so I could use Postgres, but I want to use Postgres with vector database support. So I'll bring in this PG vector support in Spring AI. And then what else do I need? I need a way to map my data objects to tables, so I'll use Spring Data JDBC, okay? I'm going to go ahead and hit generate, and we'll open this up in our IDE, and it doesn't all that much matter what IDE you're using. I'm going to use IntelliJ. Who's using IntelliJ? Neat. Who's using Eclipse? Nifty. What about Emacs? Okay. Visual Studio Code. All right. Well, just, you know, you never know. These things, you wouldn't believe the way these the hands have changed over the decades. Okay. So we have an application. Like I said, it's a data-centric application. Can you see? Of course you can see that. It's enormous. It's like a building. Yeah, okay, never mind. So we're gonna create a credential here. So Spring Data Store URL is jdbc colon postgresql localhost my database. Okay, don't tell anybody. And then the username is my user, and the password is, and this is a secret. Okay, it's just called secret. Don't tell anyone that. Okay. Okay. So we've got our database. Let's create a connection here. We'll have IntelliJ give us a little console. Hit apply. Hit OK. Go over there, refresh this, double click, my database, public, tables, dog, okay? And you can see we've got some records in there. We've got a dog record, ID, name, description, and owner, okay? And down here we can see our dog Prancer. Number ID is 45, the name is Prancer, and he is described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like gremlins, right? And the owner is null. And so what we want to do, or don't want to do, is adopt this dog, okay? And it's not a good result, because then I will have two terrible dogs, which is, it doesn't feel like a win exactly. But okay, so that's what we're going to do, okay? Now, I want to build my code in a modular way, okay? When I say modular, remember, I'm going to create a separate package here, okay? And it's going to be called adoptions. And the reason I'm going to do this is because I want to have a class, an endpoint that I can hit to support the process of adopting a dog, okay? So I'll say, at dog adoption controller, and I'll put that in this code page. Now, I'm creating this in a separate package. Notice that I got rid of the word public. I want my code to be modular. And what I mean by that is I want to limit the blast area of a change. If I make a change to the code, I don't want that to impact other parts of the code. So I'm going to go to as far lengths as possible to make sure that I've limited that impact, right? And the way I do that is by embracing common object-oriented design, right? So public is anathema to that. Public is optional. Remember, you should only use public if you really need it. Things should not be public by default, right? It is not public by default in Java. You have to add public. If everything is going to be public in your code, just use C, right? You've got a global namespace in that way, right? Why bother? Just use C. It's easier, right? So I'm going to create nice object-oriented code. I'm going to have a package private types. I'm going to make sure that I do a good job of keeping them modular. And the reason, it's not a technological discussion. This is a socio-political discussion, right? The less work I have to do to keep everyone in my organization aware of the changes, the faster I can make changes, right? That coordination cost is the bottleneck. This is the same idea behind microservices. Microservices are not technically, there's more moving parts by definition. It's not technically simpler than just having a monolith, right? What we're building here is a monolith, but we're doing a modular monolith. And the reason is because we want to make sure we have a very clear, well-delineated boundary along which we can allow change, and inside of which we keep our changes to ourselves, private, right? So, and that means that we reduce the cost of coordination. So, okay, we've got this dog adoption controller. We're going to create a entity here. So I'll say record, ID, string name, string description, and of course, string owner, okay? And this is going to be an entity, so I'll map it to an entity. And I love Java records. Such a fan, big fan. Okay, so that's nice. So I'm going to use records there. This is actually part of a number of features in Java 21 that support what is called data-oriented programming, about which I'm sure you already heard some at this very conference. And the idea is that you have smart switch expressions, you have records, you have sealed types, and you have pattern matching. I can't type at an angle. That's what I'm realizing today, friends. So sealed types and then pattern matching, okay? So these things are all really powerful. They work together in a synergy. We don't have time to get into it, but basically, don't sleep on records. This is just the beginning of a whole new opportunity, okay? So we're going to create a dog repository that extends list of CRUD repository, managing entities of type dog whose primary key is of type integer, and there we go. So there's that. And now I want to have a method here called void adopt. And in this, I'll take the dog ID, and I'll take metadata from the request in JSON that has the name of the owner, okay? So, and I'm going to call this at post mapping /dogs /dog ID /adoptions. And so you can post to that endpoint, and this will be the path variable, and this will be the request body. Okay, so request body, et voila. And what I need to do is I need to inject now the dog repository there, so private final dog repository. Inject that into the constructor, and we'll just make a simple call. I'm going to ask the repository, hey, do you have this dog? If so, let's work on it, right? So I'll get the dog here, And I'm going to create a new dog like so. I'll say new dog. Here, I really want Java to add support for withers. Basically, I can say dog.with and then clone the existing object, right? But it's not here just yet, so it's fine for now. We'll just do this. So it'll be name, and I'm going to save this. I'll say this.repository.save, like so. Save that, and that, okay? And I'll say system out adopted this dog, okay? Just printing out the dog that I've adopted. Very good. Okay. Do you guys hear that? Oh, you hear it too, right? I'm not having a stroke? Okay, good. Whew, you never know. Okay, good. So let's go ahead and, I think we're okay. That looks okay to me. So let's go ahead and start the application up. Okay, up and running. And we go to the console here. And what I'm going to do is I'll say curl, and then send my name in. And we see over here, it says adopted, dog ID 45, name is Prancer, description is a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin, and the owner is now Josh. So I've done it. Yay. I've adopted this dog. Okay, but the problem is that when you adopt a dog, there's a lot more that's going to happen besides just changing a field for the record, right? So this is not actually a realistic example. More invariably, you're going to have other things that need to be involved in this process. Maybe I need to schedule the appointment with the dog doctor, right? The doctor that sees dogs, the veterinarian, right? So let's call that the vet. Okay, we'll create a service here, another module called vet, and in that vet, here we go. In that vet module, we'll have a class called vet. You know what? No, dog tour. There you go. Okay. So we'll say public void checkup int dog ID. Okay. And I'll say, okay, checking up on dog ID. So I now need to use that type in this code. So I'll inject that here. I'll say private final dog tour. Okay, and I'll add that to the constructor. And down here, before we print out the confirmation, I'll have it pass in the dog ID. Very good. So now if I rerun this code, what do I get? Well, go here, and I get checking up on 45. That's worked fine. Invariably, I might have, these might be part of an overarching transaction, though, so maybe I make this transactional, right? That's okay, but the problem is I don't care about the result of this. There is no result. It's void, right? It's a thing that I'm launching, but I don't care about the outcome. And in fact, arguably, this isn't even part of the same domain. This has to happen, but I don't need to worry about it, right? It's not something that I, as somebody who's doing the adoption, care about. So I don't need this. I need this to happen, but I don't need to be here. And that's one thing you got to guard against, is having objects that are too busy, too many responsibilities, too many collaborating objects, right? You end up getting these so-called God objects, which do too much and become very, very painful to test, right? So let's back out that change, okay? Or remove that dog tour from our code. How else can we integrate? Well, we can use events, right? And this gets me to one of my favorite blogs by Martin Fowler that was written in 2017 before the COVID pandemic, or BC. And what this blog asks is, what do you mean by event-driven? Well, there's 4 different types of uses for events and messaging in the system. Event notification is where you send the fact of the event to another system. You don't tell them what the details are. You just say something happened. And if you know what to do, great. If not, maybe you're going to need to query the source system. Oh, yeah. Good stuff. So maybe you're going to need to query the source system. Maybe not. Who knows? And then you get to event carried state transfer. Here, you're sending the details of the change to the other system. So the other system can act on the event rather than having to query the source system. So you've decoupled them, right? And this is very useful if you have lots of different services and lots of different components that need to know about and do something in response to an event. So imagine you've got a system where you've got Redis, something maintaining a Redis cache for fast, constant time lookup, and you've got something over here maintaining a Elasticsearch, full text search index for for a search engine kind of functionality, and maybe you've got a Postgres database. So maybe you send an event saying, hey, we added a product to the catalog, and that updates the cache, it updates the full text search, it updates the SQL database, etc. And each message contains the deltas of state in the system. And if you have all the deltas of state in the system, in your system, in the messages, then you can do something called event sourcing. And in event sourcing, it's really nice because that is the single source of truth. You can delete Redis, you can delete Elasticsearch, create a brand new one, reset them, and then replay all the messages that you've ever been given in the order that you got them, and you'll have the same Elasticsearch and the same Redis, right? Because that is the source of truth. And it's nice because if you have a cascading sort of bug that's been in the code for years, and you have calculations that are derivatives and all that kind of stuff, you can reset the value, fix the code, not a bug in your code, surely, but if I had a bug, I could reset the value and then replay the messages and arrive at the correct derived value there. And this is really nice. These patterns play very nicely with the idea that I have multiple data structures optimized for different read or write sort of scenarios, right? I'm reading constant time from Redis, and I'm reading constant time, or I'm reading full text, doing search engines, fuzzy text search engine kind of stuff from Elasticsearch. That insight is called CQRS. So all these patterns are very simple, but they start with the humble message or the humble event. And would you be surprised to know that Spring has an event bus that's been in Spring for literally decades, right? Since well, let's see, Application Event Publisher. This was added in Spring Framework 1.1.1. And I love the history of Spring, right? If you've ever been to this website before, you can actually play this home game as well. It's spring1.io/history of Spring. And it's a video game where we all win. So here you can kind of see the origin of Spring Framework and the projects, and Rod Johnson and Jürgen and Jan started the open source project 2003, Spring Framework 1.0 2004. Go down here, go into this place, and you can see the projects here. Zoom, 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 zoom. And Spring Integration 4. Now we're in the clouds. I hope that's not too subtle, right? Clouds, Spring Cloud, get it? So Spring Cloud 1.0 2015. We have Spring Cloud Task 2016. We have, come here, get over here. Spring Cloud Stream. We have Spring Cloud Data Flow, back in the water, navigation, maritime themes like Kubernetes, right? So Spring Cloud Data Flow for Kubernetes, Spring Cloud Skipper, Spring Cloud Gateway for Kubernetes. And now we get to more or less the modern era, 2022, Spring Boot 3 and Spring Framework 6. And then, of course, this beautiful art. Look at that glass. I mean, this is gorgeous, and 8-bit, which is nice. And then this. Okay, so we all win in that game. Anyway, we have an event bus, and we can use that to publish events from one part of the component model to the other, from one part of the system to another. And this is where I start to have my first public type, a dog adoption event. And I'll make this a record. I'll have a dog ID, and I'm going to publish that event. And notice that this is public. I've been very clear about what's public and what's not. Again, I'm trying to limit the scope of change. Okay, so now I say this.publisher.publish event, new dog adoption event, dog ID. Okay, and I can now go back to the dog tour, and now this doesn't need to be public anymore because it's just going to listen for the event, and that's public enough, right? So dog adoption event, and we can add that, and we do dog adoption event dog ID, and restart. Okay, so very, very convenient. Now, let's see. Am I decoupled? It looks like it. I was able to involve this while also not being coupled to it. I don't have an awareness of it. I've decoupled the sort of needing to be in the same space and needing to know about each other. But I am sort of coupled, aren't I? Because if I do this, what happens? Well, let me sleep for 5 seconds. Or maybe I'll make this like 2 seconds, and then it'll be 2 seconds, right? And then add this thing here. Voila. Okay, restart. And then restart that. And it sees it's not returning. I have to wait 4 seconds, don't I? So I'm in the same thread, aren't I? It's dispatching those events across all the other components in the same thread. So I'm temporally coupled. I don't want to be coupled that way, right? I want to be decoupled temporally as well as locationally. So one thing I could do @async, right? Restart like that, and then reinvoke the same request, and it returns immediately. And you can see it says adopted, and then checking up on, and all that. So I get my wish. I'm no longer in the same thread, which is convenient. It's not convenient because now I'm no longer in the same transaction, for example, right? But I am decoupled, at least. It's a separate thread. I guess I could start another transaction, but this doesn't actually give us what I want, does it? Because if the first thing works, but this fails, then I'm now in an invalid state, aren't I? What if I'm running this checkup, scheduling the checkup, and then halfway through this 4-second wait, I pull the power on the machine? Well, there's no power in this case, but if it were like an actual server in production, what if the power goes out, you know? Now this isn't going to finish, or something goes wrong, or whatever. This isn't going to finish, is it? So I'm now in an invalid state. So what I want is some way to make sure this gets processed no matter what. So what we can do is we can use Spring Modulith, and it has this nice annotation called Application Module Listener, which is semantically equivalent to those other 3 annotations, right? And this has a superpower. It pairs really nicely with Spring Modulith's ability to republish outstanding events And in order for that to work, of course, you need to initialize the schema. So I'll go ahead and restart that. Okay, and I'll publish the same event. It returns immediately. I'm doing adopted. I got the checkup. But if I go over here, I hit refresh, I got an event publication table, right? And it's got the listener ID, dogtour.checkup. I've got the event type, dog adoption event, the data in the event, the publication date, and the completion date of the listener, okay? So if I do it again, refresh, you can see it's got it's null, right? It's finishing, and give it a second, and now it's finished, okay? So now I can do it one more time, and I'm going to stop the program. So it's started the event processing, but I pulled the power in the machine. Now what? Okay, I'm in an invalid state. Well, now I can restart the process. Here we go. I don't know why I started it in debug. Okay, so you can see as I did that, it's checking up on 45, right? So it's republished the outstanding event, and eventually it's finished it. So now I've got this nice decoupled behavior. I've got nice guarantees about publication. And of course, this is all within the same bus, the same code base, the same modulith. But of course, if I had other microservices that needed to be involved, well, I could use Spring Modulith's integration with other messaging systems and then add the externalized annotations. So I could say target equals adoptions. This is like if I'm using RabbitMQ, this would be the queue name. And then I can say, this is the routing key. Okay? If you're using Kafka, you just specify that, I think, right? So either way, if you set up Kafka or you set up AMQP in RabbitMQ, this will do the right thing. Okay, so that works quite nicely. I've got integration with other microservices. I'm modular. What does modular mean? Well, if I go here, if I go to Service Application Tests, I can actually ask Spring Modulith what it means. I can actually enumerate that. I can say application modules, .of service application.class. I can print out the modules, right, like this. Come on, Josh, you got this. There we go. I can actually verify the state of the modules, right? I can say am.verify. Come on. There we go. And I can even document the state of the module like that. Verify this, and then write the documentation. So let's run that test here. Okay, and so far it looks green. Good. And if I scroll down, you can see I've got a logical awareness. Spring Modulith knows what kind of modules I've got. A module is a root package and the types beneath it, okay? If you have a package below this root package called adoptions, if you have another package, that's called a package private package, right? And that's where you keep details related to this module and nothing else, right? And so you can make things public in there as long as you only use them in this root package, for example. So this actually runs ArchUnit. It runs architecture rules to validate the architecture of your code. It helps you stay on the straight and narrow and get good modular code. And because we can see that we have these modules here, well, we can also enumerate that and create sort of representations of that for you automatically, right? So for example, it generated a plant UML diagram of the C4 architecture, a C4 diagram using plant UML of the architecture of my code. So no longer do you have a architecture diagram checked into a wiki page that has drifted from the actual modern state of the code. You drew the diagram 2 years ago, and now it's different, right? So this is a very good result. I have modular code. I've got messaging as a nice way to decompose things, and I can inject things from one module to another if I need to, but you want to make sure you do it in just one direction. You don't want like bidirectional sort of tangles as well. So the Spring Modulith support will help you detect and avoid that mistake as well. Okay, so I've got modular code, and I like this approach. I like having nice, clean code bases, but we're still not done. I was able to successfully change the name for that dog, for the owner, but how did I find out about the dog? How do we know which dog we're going to adopt? I knew about him because I saw the ad on Facebook, right? And I saw the ad on TV. It went viral. I knew about Prancer because of that. But what about these other dogs? There's going to be questions you're going to have to ask. So I want to build an assistant to help make this process easier. So I'll go here. I'll build a class called an assistant. And this is just going to be a thing that'll help people answer questions about the dogs in the catalog, or I guess the dogalog. Okay, so we're going to create a assistant, and in order to do this work, we'll use Spring AI, and we're going to use the very convenient chat client, which is a client that you can use to talk to a different model. So I'm going to say, builder.build, and there's that. And in order for this to work, of course, I need to specify a few things in my configuration. I need to specify OpenAI key, right? API key. Well, friends, I've already done this. I've already done this off screen, so forgive me for not leaking my API credential. Just trust me that it's been done, okay? You might also want to specify the model, so OpenAI chat model. You might want to specify a different one here, but I'm happy with the defaults. So all that is there. Just be aware that you need to specify that when you set up your application. I'm going to use OpenAI, but Spring AI supports dozens of different models. You don't have to use OpenAI. You can use Ollama, which runs completely local and private and free, you know? So all sorts of different options, right? Hugging Face, you can use that. You can use Gemini, you can use Mistral, you can use Amazon Bedrock. There's all sorts of different integrations here. And so, okay, I'm going to build an assistant. I've got my chat client there. And remember, we're going to build a dog adoption service called Pooch Palace. So we want to build an assistant to act as an employee of this fictitious dog adoption agency. So client.prompt.user, and we will ask, hey, do you have any neurotic dogs? Okay, .call.content, and that's the string that we'll get back. Okay, and I'm going to print this out. Here we go. Content, voila. And content like so. Okay, so let's run that, and I'll go here and just run this program again. So here we go, restart. Okay, so now it's gonna, let's see what happened. Oh, I didn't define something correctly. What did I fail to do? The bean assist, oh, do I have two? I do have two. I have two assistant runner. Okay. Okay, so it's calling out to OpenAI. Hopefully nobody's torrenting, and it says, hey, I don't have any dogs, which is a funny thing for an AI to have to explain to us. We get it. You're an AI. If you had pets, I would be very surprised. And a lot of times, it says, hey, I can offer some advice. So it's trying to be helpful, but this is clearly not what we want. Remember, this is supposed to be an assistant that's helping us represent our fictitious dog adoption agency. So we need it to act like that. And one way to do this is to give it a system prompt, and that's what I'll do here. I happen to have a system prompt. So desktop system, pb copy, and we'll configure that system prompt. That'll inform its overall tone and tenor, right? It's the framing against which, against which it answers all of our other questions. So we're going to say to it, you are an AI-powered assistant to help people adopt a dog from the adoption agency named Pooch Palace with locations in Antwerp, Seoul, Tokyo, Singapore, Paris, Mumbai, New Delhi, Barcelona, San Francisco, and London. And we'll say, information about the dogs available will be presented below. If there's no information, then return a polite response suggesting we don't have any dogs available. So we're going to specify that as the default system prompt. So system. Okay, here we go. And let's just rerun the same query, having done nothing else besides that. Okay, and they'll see what it gives us back. Okay, I'm sorry, but we don't have any specific information about neurotic dogs available for adoption at Pooch Palace. However, you're welcome to check with the nearest Pooch Palace locations for the most up-to-date information. Let us know if there's anything we can assist you with. Great! It's acting like it should be able to help, but it can't, right? You might be forgiven for thinking you're talking to like a human being behind a computer that, for whatever reason, is unable to access the terminal and bring up the console that shows all the inventory of dogs in the doggo log. Okay, so this is good, but it's still, we want it to be able to help us. We want it to know about our data. And this is the heart of AI engineering, is teaching your models how to access your business logic and how to access your data. Remember, most enterprises are going to consume AI. They're not going to build their own models. They're going to consume it and integrate it. And here, Spring and Java are second to none, because most of these applications are in Spring and they're using the JVM, and your business logic is there. And these services are guarding access to your databases. So this is a natural place to do those integrations, right? And that's the core of AI engineering. And in particular, there's this pattern called RAG, Retrieval Augmented Generation. And the idea with that is that you send the data that you want you want the model to analyze in the request so that it can provide a response. But you don't want to send all your data, right? I mean, these models today can support a lot of data, but still, it's very unreasonable to send your entire database on every single request. You just want to send the results that might plausibly match. And so to support this sort of filtering process, this sub-selection, what a lot of people do is they put it in something called a vector store, a vector database. And these vector databases are optimized for similarity searches, for finding similar things, okay? And there are many different vector stores, right? If you go back here, Spring Initializer, and look for vector, you can see we got Milvus and Neo4j and Pinecone and Weaviate and Oracle and Qdrant and Azure and Apache Cassandra and Chroma and Azure AI and Elasticsearch and MongoDB and TypeSense, and the list goes on. In fact, we even have an in-memory one here. that's in Spring AI. And you would be surprised. It's not even that much code. It's like 266 lines of Java code to get an in-memory implementation. We don't recommend you use this in production, but that is to say, it's just math, right? It's not all that hard to do, okay? So we're going to use the PG vector store implementation that we have. In order for that to work, we need to tell Spring AI to initialize the PG vector schema, not to validate it. We want to initialize. Okay, there we go. And that's it. And then we're gonna take our data from our SQL database and then write it out to the vector store component like this. So we'll go through the data. I'll say repository.findAll. Actually, I'll take this code and I'll put that in the where we build up the system up here. Okay. Good, good. And we'll go down here now to this, and we'll say repository.findAll.forEach dog, and then we're going to create a document that has information about the dog. So ID, %, name, %, and description. This is just a string, okay? And it's going to have some information in it about the dog. So ID, dog.name, dog.description, and maybe we'll have some metadata so that we can source the original document back. So pass in the dog.id. Good, and then we want to write that out to the vector store. So we say vector store.add list.of, and then pass in the document. Now this is a document that refers to and works with dogs, so obviously document. Okay. Okay, so there's that. Let's run this. This is going to write it to the vector store, but our model, our client, doesn't yet know to consult that vector store to find things. Now remember, we're using Java here. We're using the JVM. This is not PHP and JavaScript. We don't waste time writing nonsense code that nobody wants. I woke up this morning and I said, I want to write a retrieval augmented generation pipeline. I wrote one line of code and I got a retrieval augmented generation pipeline. What did you do today? So let's go ahead and run this. So that's going to initialize this PG vector store schema here, right? And you can see it's got 6 records. It's actually calling the OpenAI embedding endpoint. And it's creating embeddings for all the data one by one. This takes a little bit of time. Here we go, 18. And it says, yes, we do have a neurotic dog available for adoption. Prancer is described as a demonic neurotic dog. If you're interested in learning more about Prancer, boy am I, or arranging a visit, please let us know. Great, right? We did it. We found our dog. But this is a full text string. It's not exactly an API object that I have a schema that I'd have to parse this, wouldn't I? I'd have to look for the name or something like that. So what I want to do is I want to tell Spring AI to ask the model to give me this result back as a type that I can use in my API. So I'll say dog adoption suggestion, int ID, string name, string description. Okay? So there's that type, and instead of getting a string back, I'll say entity.class, and then rerun the exact same query, having done nothing else. Okay. So, I forgot to avoid the reinitialization. That's a bummer. Hold on, let me pause that. I don't want to initialize everything twice. It's slow. Actually, in fact, the matter, I need to get rid of this, because I just ran it. It's got extra data. Okay, so we'll do it one more time. Here we go. Got the new vector store table, and it said, wait, reinitialize. Oh, I did comment it out. Sorry. It has no data in the database, so of course it didn't give us a good result. Here we go. Let it reinitialize everything, sadly. This is so sad. So sad. Here, where are we? Okay. There's 18, so we should have results. There we go. So we got a Java object of type dog adoption suggestion. The ID is equal to 45. The name is Prancer, and the description is a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin. So it's worked, right? We've got a Java object that we can use in our system. Let's go ahead and definitely comment out all these other things. That I don't want to reinitialize the schema there or there, and I don't want to do validation either. So I'll say Spring AI validation, right? So false. Okay, so good. So that's a good result, right? We've got our basic assistant all working. We're able to find our dog. We're able to adopt it. I think we're ready to turn this thing and take it to production. And here, friends, we have some questions we need to ask before we can take it to production. 3 questions I want to concern myself with before we can take this code to production. The first of which is our code efficient? Is it efficient? Is it efficient enough for production? And friends, the answer, of course, is yes, right? We're using Java. I mean, Java's an amazingly efficient language. How many of you have seen this blog which asks the question, which programming languages use the least electricity? And this is from May 20th, 2018 BC, okay? So you go down here, and you can see it's a table that shows the normalized global results for energy, time, and memory. And you can see that of these languages, C is the most energy efficient, okay? That makes sense. It's 1.0. Rust, zero cost abstractions, well done, coming in number 2. C++, tooey, disgusting. Moving on. Ada, no one cares, and then Java, okay? Now Java is, we can call it 2.0, round up, 2.0, okay? So Java is twice as inefficient as C. Okay, fair enough. But notice that this is a virtual machine. That's what the V is, whereas these first 4 are compiled. So one can only wonder what would happen if Java was actually a compiled language. That's called foreshadowing, friends. It's foreshadowing. Just keep that in the back of your old noodle, okay? Good. So look at a bunch of these other numbers here quickly. You've got C#, it's pi. That's nice, right? Pi. Well done. You've got Go, away. You've got these 2 terrible languages, the less said about which the better. I don't understand how come this is 4 or 5 times worse than that. I thought TypeScript transpiled into JavaScript. How? What is the delta here? Look at that. It's crazy. That's 15 points less efficient. Okay, moving on. And then we have these 2. And this is JRuby. Now, friends, JRuby is Ruby implemented in Java. And Ruby is Ruby implemented in C. And yet the C implementation is almost a third less efficient than the Java implementation. And the reason for that is, I think, pretty clear to see. The JVM is boss sauce software. It really is really good software. And then we get this. Friends, that's 76. Let's round up, okay? I don't know what I'm not very good at math, but remember, Java is 2. This is 76. You know who is good at math? Freaking Python. So 76 divided by 2 is 38. So if I write a program, that program takes 38 times more energy to do the equivalent thing. That's worse than Bitcoin. That's really bad for the grid, Not a fan. So anyway, moving on. I forgot what I was talking about. Oh, right, Java. It's awesome, okay? So the answer is yes. Very energy efficient. The next question, is it scalable? Is our code scalable? Well, yeah, of course. To the extent that our code is able to do more things quickly, we are scalable, because the faster we can handle work, the faster we can move on and do more work, right? And so yes, it's scalable, but there's a lot of things in the world that are sort of beyond our control. There are externalities for which we have to wait, like that call to the OpenAI endpoint, or a SQL database, or a microservice, or whatever. These are network calls that I can't control the speed at which they run. I am stuck waiting for them. And there, I'm at the mercy of my ability to spin up new threads, because each request, typically in a servlet container like Tomcat, is 1 request per thread. But if I'm sitting there waiting for these operations to happen, then I'm bottlenecked by my ability to spin up threads. And threads are not cheap on the JDK until recently. Java 21 has this nice feature called virtual threads, right? And virtual threads are awesome. So let's take a look at that here, okay? Virtual threads give you the ability to really, really dramatically improve your scalability. So let's do that here. I'll go here, and I'm going to take a demo from my colleague, Cora E. Berkeley. She's awesome, Cora E. Berkeley. Follow her on Twitter or wherever. Okay, and I'm going to steal this from her, and it's just a simple example. Okay, so delay, string delay, and what we're going to do is we're going to make a network call to a website here. So REST client, HTTP. And we'll say this dot http dot get dot URI https http-bin.org delay 5 seconds. So that's going to call that website and simulate a 5-second delay before it gets a response. That website actually artificially blocks. Okay, and in order for this to work, I need to have the REST client. So let me define that bean over here. And so I'm going to run this endpoint in Tomcat. It's a Spring MVC controller. So I'll run that in Tomcat. I'll say return builder.build. Voila, let's start up the application. And I'm going to just send some traffic to it. So I'll say, hey, minus 40, that's the number of total requests total, with 20 concurrent, calling localhost 8080/delay. Okay, so that's going to make a number of requests to this endpoint, and I'm not using virtual threads right now, so we'll wait for these responses to come back. Okay, hurry up, hurry up, hurry up. Come on. Okay, so we got 200 status code on all of them. That's nice. Here's the total time and all that kind of stuff. Okay, good. Yuck. Okay. Yay. So now we have to refactor our code to take advantage of virtual threads. This is not for the faint of heart, but I think we'll be able to get through it. Okay, it's done. So let's go ahead and restart. And we'll run the same exact request. Okay, here we go. Come on. Come on. Okay, there we go. What happened there? I feel like did that website, why are these results not different? So, slowest, I think we're getting some weird results here. Let me check out that, is that website actually the right one? Service application, HTTPS. Yeah, looks like it's doing the right thing. Yeah, okay, that's the right endpoint. Okay, good. Well, let's check out the results. Usually the results are like double sometimes, but okay, so the average was, I don't understand actually, do I have this property set somewhere else? The slowest was 8 seconds, here it's 6, so that's a little bit better. Usually when I do this result, usually it's like, this is like 20 seconds and this is like 13, right? And the slowest is oftentimes 3 or 4 times slower than the fastest, right? When it comes to the old non-virtual threads. So the results are, and here, even here, you can see we got like 2.8 versus 3.2. Usually it's like 1.5 versus 3.0. You know, it's literally double. So I'm not sure what just happened here, but normally virtual threads are a big win. Oh, you know what? You know what it is? I forgot to make my code more representative of production. I forgot to create contention. If there's no contention, then there's no queuing, and there's no problem with resource sharing. I'm going to do this one more time. Here we go. Okay? And the reason you want to do that is because, remember, these machines that we run today are amazing. Okay? I have an incredible, incredible machine. I can run both Slack and Chrome at the same time. Okay? It's an incredibly, I know. Scientists didn't think this was possible a few years ago. Here we are. There's videos of nerds in labs with white coats trying to run both, and the computer would explode. It's just not possible. It's not possible. It creates a singularity around your RAM. So, here we go. That's with virtual threads, okay? Yay. Yuck. We have to do yuck now. So we go, yuck. We go back here, and now I'm going to say, I don't want that. Restart. Okay, restart again. Come on, machine. Come on. Hurry. This is the slow one. This is why this is the worst one to run at this particular juncture of the talk. But here we are. Come on. Come on. Okay. There we go. So that's more like it. See, given contention, these numbers kind of speak for themselves, right? And this is more representative of what you have in a production server, right? Right now, if you go to cloud infrastructure, you're going to get commodity machines. You're not going to get these crazy fast machines that we have on our laptops at home. So the total with virtual threads is 12 seconds. Without them, it's 22 seconds. The slowest is 17. Here, it's 7, right? When you have the fastest, it's 5.1. Fastest 5.1 that tracks. The average is 8.8 in the non-virtual threads. The average is 5.7. And here, it's literally double. Right? So the results, I think, are pretty impressive. Virtual threads are free win. They're awesome. So that's the answer then there is, yes, it's scalable. Okay? Really good. So next question. Is it fast? And friends, obviously our code is fast. You've all seen, I'm sure you've heard about the 1BRC, right? This is 1BRC. And here, 1BRC is, how fast can you load 13 gigabytes of text data based on weather station telemetry data. This is started by my friend Gunnar Morling, a fellow Java champion. And in it, he asked people to submit a plain Java solution to load 13 gigs or 1 billion rows of data. How fast do you think the fastest one was? Well, it's about 1.5 seconds, which is fast, right? Here's 1.58, here's 1.6. and here's 1.88. Now the fourth one is using stock standard OpenJDK, but the first three are using GraalVM. So that's what we're going to do. We're going to go ahead and create a native image. But of course, you have to account for some of the dynamic things that you do in a GraalVM native image, including reflection. So when I make that call to get the dog adoption suggestion back, I need to actually tell GraalVM that I'm going to do that by registering it here. So let's go to the command line here. Go to the cd service, and we'll do maven skip tests p native compile, and we'll let that run. Okay, so this is going to take a little while, and this is my least favorite part of GraalVM native images. It is my least favorite part, and the problem is I get bored very easily. So now I understand this XKCD cartoon, right? This one, it posits the #1 excuse for not doing your work is my code is compiling. I got this joke now. I thought this was for the C++ people, but no, it's us. You know, I don't like that at all. And I get really bored, and I hear music, elevator music, in my head when I do these native image compilations. And so I thought, wouldn't it be great if everybody could hear native images, hear elevator music? So I went to Oracle, and I said, Oracle, please play elevator music during the native image compilation. I got this responses, and a lot of them were good, but I got this one from my friend Fabio Nipaus. He's a doctor, one of my favorite doctors on the GraalVM team at Oracle Labs. He says, thank you for the feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Go on. I have prototyped a -- Josh Long mode. So what this would do, friends, is you call native image -- Josh Long mode, hello world, and then you're hearing music. This is a picture, but imagine you're hearing music and you're confused. You're like, where's this music coming from? Who did this to me? Why is it happening to me right now? And then it says music brought to you by Josh Long. So you're like, you're more at comfort, more at ease, right? You know what's happening. You're going with the process. But still, you're waiting. You want something nice to look at. So then it prints this out, right? And I think that's going to be great. I'm sure that'll get merged soon. That's me, by the way. You can't really see. I'm wearing that T-shirt there. Okay, so I'm sure that'll get merged soon. I don't know when. What were we talking about? Oh, the compilation, right. Okay, so that finished. So we go here, target, run the application again. Okay. Oh, port's already in use. Let's go ahead and stop that here. There we go. So 0.2 seconds, like almost 8 times faster. And much more importantly, if you look at the process identifier here, PS-O RSS. This is the RAM measured in kilobytes. So I divide by 1,000, 171 megs. Let's go to my least favorite browser ever. You can hear the electricity in the room. Business. Okay. And then look at that. It's still loading. The JavaScript app is just loaded. 821 megs. Friends, we live in an amazing time. I've been able to adopt, now I have 2 terrible dogs, and we were able to do that with code that starts up in no time at all. It has AI, it has observability, it has a web server, it has data access. It's modular, it's sustainable, it's scalable, it's production worthy, it's fast. It's an amazing time to be a Java and Spring developer. I hope I've persuaded you of that. Who learned something new? Who had fun? All right, me too. Thank you, everybody. Thank you so much. Have a great day. Please vote. I want them to invite me back.
All systems are nominal. Initialize Genesis sequence.